Alright, in this video, I'm just going to work through a bunch of chain rule examples. So my first one, and I'm going to do this the substitution way, because then I will do a second video for those of you that like my shortcut way. So if you like the shortcut way, stay tuned. That'll be coming up next. Alright, so again, what we're looking for is the inside function, which is pretty easy on this one because it's inside parentheses. And then my outside function in terms of that inside function, which would just be y equals u to the third power. So this is what we're kind of doing over here on the side. And what we want to do is we want to take the derivative of both of these. So that would be 3u squared. This one would be 6x squared. And then finally we multiply these together. So as you can see, let me just do it over here now. If I multiply these, I'm going to have 18, and let's just put the x squared first, times u squared. So finally my last step is I plug in what u is, and I get 18x squared, u is 2x cubed plus 1, and then don't forget that nice little squared there. Alright, so I'm going to bring up another one. So if I try another one here, let's get that one kind of out of the way. I have dropped my stylus. I have r equals q to the fourth plus 1 all to the sixth power. So this is kind of just like that last one, where my inside function is what's inside the parentheses, and then my outside function is u to the sixth power. I take derivatives of both functions, so that's my power rule, for q to the third. Don't forget that goes away because that's a constant, and the derivative of a constant is 0. Now I multiply these, so I'm going to have what, 24 q to the third, u to the fifth. Sorry, that's a 24 there. And last but not least, plug back in what u equals to get your final answer. 24 q to the third, u is q to the fourth plus 1, all to the fifth power. So that would be your final answer on that one. Alright, let's try to do something a little bit different. So let's look at one that has a radical. Y equals the square root of s. Let's do a cursive s so you can tell that's an s. To the fifth power plus 7. So typically we write radicals to the, or square roots in this case, to the 1/2 power, or any radical to its rational exponent, because when we do that, then we end up with a power rule. So my inside being s, sorry, I didn't do my cursive s, s to the fifth plus 7, and my outside being u to the 1/2 power. If you remember, I said this is the derivative of square root of x, which is 1 over 2 square roots of x. I said remember that, because it makes it very quick and easy to find that derivative. And then over here, I'm going to have 5s to the fourth power. So when I multiply these, basically all I'm going to do is put the 5s to the fourth up top. And I get this. My last and final piece to get my final answer over here 5s to the 4th all over 2 square roots of s to the 5th plus 7. Looking good, so far so good. Let's do something with an exponential. So this next one is y equals 2e to the 8t plus 3. So over here on the side, I'm going to let u equal everything in the exponent. So that's what I'm calling the inside piece. And so then the outside piece would just be, and you probably didn't matter, but might have wanted to use a different variable, but who cares? Y equals e to the u. The derivative of e to the u is e to the u. The derivative of 8t, remember that's a linear, so that's just 8, and of course 3, the constant goes away. So we get 8e to the u. Our final answer over here, I simply plug back in what u equals. But I don't forget that 2. Some of you might be saying, well, what happened to the 2? I forgot it, and then I just wrote a 12. It won't let me undo it, so I have to multiply by 2. So I get 16e to the 8t plus 3 for my final answer. So all I did was this 2 here. I didn't worry about it over here. I mean, you could have brought it over here if it makes you feel good, but I didn't. I just didn't worry about it. Alrighty, so let's see if I have something like w equals 6e to the square root of s. So let's do this one where I bring the constant over so you can see how you might do that. So my inside is this whole square root of s. My outside would be 6e to the u. The derivative would be 6e to the u, because the derivative of e to the u is e to the u, and the constant comes out front. Up above, we just said this derivative you want to learn very, 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 very quickly. Uh-oh, I hit undo accidentally. And so now putting these all together, meaning multiplying them, I get 6e to the u over 2 square roots of s. Of course, 2 will go into 6 3 times. So over here, my final answer is 3e to the u. Don't forget to plug that u back in over what's left on the bottom, the square root of s. Let's do a log. I haven't done a log yet. Y equals ln of 5t plus 4. What's inside the parentheses? The 5t plus 4. What's on the outside? Oh, let's just use w since that's a y already. So what's on the outside is going to be ln of u. I take this derivative, which is 1 over u. I take this derivative, which is 5. I multiply them, and then I come back over here to get my final answer, 5 over u, which u is 5t plus 4. Even if there's more going on inside here, so this is given as f of t equals ln of t to the 7th plus 8. Alright, over here on the side, I'm going to have u equals t to the 7th plus 8. Y equals ln of u. So this is still 1 over u. In this case, we just have a power rule, so that's the only thing that really changed. So I get 7t to the 6 over u. So my final answer, f prime of t, notice just a different way of writing this. And then I plug in u, and I get my answer. And now I can't see any more problems because my cat has jumped up in my way. So let me move things around. Okay, so let's keep on going. Next one I have f of x equals ln of 7 minus e to the minus x. Over here on the side, this becomes u equals 7 minus e to the minus x. Y equals ln of u. Y prime 1 over u. U prime, the derivative of 7 as a constant is a 0. So let's just put it there so we kind of keep our signs together. Minus the derivative of e to the negative x, which is e to the negative x times negative 1. That negative 1 actually came from another chain rule, came from taking the derivative of negative x. And remember, that's like saying negative 1x, which would be a linear. And so that's how I'm getting negative 1. So then I would multiply these. So this negative and negative is going to give me a positive e to the minus x over u. And then my f prime, my derivative, is going to be e to the minus x all over my u, which is 7 minus e to the minus x. And just one more. Again, this one's kind of the same as this last one. Y equals 4 plus ln of 3t plus 2. So I know when I take the derivative of 4, that's going to become 0. So I don't even have to worry about that piece. So I'm going to have my u equals 3t plus 2. My y equals ln of u. Y prime 1 over u. U prime 3. So 3 over u is my answer. Or putting it back in the correct form, 3 over u, which is 3t plus 2. And we are done.